Okay, 7-3 special right triangles. Objective: students will be able to use properties of 45, 45, 90 and 30, 60, 90 triangles. What we mean by that is in these drawings below, 45, 45, 90. So it has angles 45, 45, and 90, or 30, 60, and 90. So that's talking about the angles there. What I want you guys to do is I want you to solve for the missing side in each one of these. So in the next sheet, you're going to be given some numbers, and you're going to use these pictures to solve. For example, let me do the first one with you guys. For example, they're going to tell you that this one is 1 and this one is 1, and you're going to find the missing side, the hypotenuse. So you're going to use Pythagorean theorem that we learned yesterday, and actually we learned a long time ago, but we reviewed yesterday. A squared plus B squared equals C squared, and we're going to plug in the information. Well, we could have either one of these sides be A and either one be B. It doesn't really matter because they're both the same thing, right? So 1 squared plus 1 squared equals C squared. Well, 1 squared is just 1, so I have 1 plus 1 equals C squared, or C squared equals 2. And if I wanted to solve that, I'd take the square root. And so I could say that this equals square root 2. And you're going to be given a bunch of other sides, and I want you to keep finding the solution. Simplify it all the way down though. Okay? So keep finding the solution to the hypotenuse. Over here, you're going to be given something else. They're going to give you the shorter leg. Let's do red. And they're going to say, like for example, the first one, they'll say, hey, the shorter leg is 1 and the hypotenuse is 2, and you're going to find this longer leg, so we'll call it B. You're going to find B. So you're going to have to write this equation out as 1 squared plus B squared equals 2 squared, because that's your hypotenuse. So 1 plus B squared equals 4. Subtract 1, and you get B squared equals 3. Take the square root, B equals rad 3. Alright, so this is rad 3. And so you're going to solve this one for B all the way down. And I want you to see if you could find a pattern. In both of these, there is a pattern that you should find. So go ahead and try that. You may want to hit pause as you do that, and then I'll put up the answers to see what you should have had. Okay, bye. Okay, after you did all the math, here's what you should have found. For all of these ones, the 45, 45, 90 triangles, you should have found when the side was 1, it was 1 times rad 2. When the sides were 2, it was 2 times rad 2. When the sides were 3, it was 3 times rad 2. 4, 4 rad 2. 5, 5 rad 2. So that's kind of interesting. That makes it really nice. Whenever we have a 45, 45, 90 triangle, all we need to do is take whatever the side is and multiply it by rad 2. And that'll give us the hypotenuse. Easy. Okay. Over here, the 30, 60, 90s, we had 1, 2, 2, 4, 3, 6, 4, 8, and 5, 10, where AB here was the hypotenuse. So right away, you should see a pattern here without even doing any math. You should be able to see, hey, for every short leg, the hypotenuse is exactly double it, right? 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. And then also, if you would have used Pythagorean theorem, plugged it all in, you would have found that the middle leg would be rad 3 here. For this one, it was 2 rad 3. For here, it was 3 rad 3, 4 rad 3, 5 rad 3. And notice, this is 1 times rad 3, this is 2 times rad 3, 3 times rad 3, 4 times rad 3, 5 times rad 3. So whatever the length of the shorter leg is in a 30, 60, 90 triangle, we can just multiply that by rad 3, and that should equal the middle leg. So that's some awesome little shortcuts. You could summarize what you found down here. And let's talk about these problems. Okay, so it says if a right isosceles triangle. Okay, if it's a right isosceles, that automatically is a 45, 45, 90 triangle. And it has 2 legs, so the legs are 77. What would the hypotenuse leg be? Well, remember, we found up here, all you have to do is take the leg length and multiply it by rad 2. So the hypotenuse would just be 77 rad 2. Done. That's it. Alright, the next one says, given a 30, 60, 90 triangle, if the shorter leg was 39, could you find all the other side lengths of the triangle? Well, okay. Shorter leg, I'll just write SL, is 39. Right away, we should know the hypotenuse, because the hypotenuse is just double that, so it's 78. And we should be able to tell the medium leg, too. Or the longer leg, whatever you want to call it. Because that's just going to be the shorter leg times rad 3. And that's it. Alright. Let's move on to the next page. What do you know? Theorem 7.6, 45, 45, 90 right triangles. In a 45, 45, 90 triangle, the length of the hypotenuse is rad 2 times the length of either leg. That's what we discovered on our own. Alright, it says the sides of an isosceles right triangle. Alright, must be talking about 45, 45, 90. That's what isosceles right means. Are unknown, but the hypotenuse is 6. Find the length of the two sides. Okay. Remember that the side times rad 2 equals the hypotenuse. So let's just write that. Side, we'll call it n, times rad 2 equals the hypotenuse of 6. Divide rad 2, divide rad 2. That cancels out. So we got n equals 6 over rad 2. Well, here's the only issue, right? We're not allowed to have rad 2's in the denominator, so we have to simplify this. So we're going to multiply, or sorry, it doesn't equal. Let's rewrite that. We got n rad 2 equals 6. We divided both things by rad 2. And then to get rid of that rad 2 in the denominator, we multiply it, not equals. Multiply it by rad 2 over rad 2. That would equal 6 rad 2. And rad 2 times rad 2 just equals 2. Well, now I have a 6 over a 2. Well, 6 divided by 2 is 3, so this equals 3 rad 2. And there we go. Both of the sides would have to be 3 rad 2 in this situation. Alright. This one is for you guys to practice. It's going to be set up almost the exact same way. The hypotenuse is given. It's 8. So set it equal to what we know the hypotenuse should be, which is n rad 2, and solve for n. You may want to pause the video and go ahead and do that. Okay, so what you should have done is you should have said 8 is equal to n rad 2, divide everything by rad 2, cross those up, cancels out, multiply by rad 2 over rad 2. You would have got, when I move it over here, you would have got 8 rad 2 over 2. And 8 divided by 2 is 4, so you would have had 4 rad 2. There you go. Okay. You have just a couple more here. So this next theorem, 7.7, it's the 30, 60, 90 one. It's the one we already learned, right? The length of the hypotenuse is twice the length of the shorter leg, and the length of the longer leg is rad 3 times the length of the shorter leg. So got it quite a bit here. Again, they give us a good little diagram here. It says find AC. Okay, well this should be pretty easy. Remember we said, hey, here's the hypotenuse, so here's the shorter leg. It must be opposite the hypotenuse. So this must be 7. And then that must be 7 times rad 3. Easy. That's all we have to do there. Alright, so above, if BC is 14 now, so maybe we want to draw another triangle and call, instead of it being 14, I'm sorry, it's 20, then what would AC be? Well, again, this side over here would have to be half its length, 10, and so this would be 10 times rad 3. Easy, 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 easy. So you guys can do this stuff. Okay. Alright, here's the last problem. It involves us graphing a 30, 60, 90 triangle and locating the third point. So let's do that. First of all, we're going to zoom in and I'm going to plot these points. I'm going to plot C is at 3, 2. So there's C, and D is at 9, 2. And so there's part of my triangle. Whoops. And we're going to locate point P. Let's see, what else does it say? Oh, it says, look, angle C is our right angle. And they also tell us that P is in quadrant 1. So if we were to go down, we wouldn't end up in quadrant 1, we would end up in quadrant 4. So we know we're going to go up, and we just don't know how much we're going to go up. Well, we need to first find this length here. And CD is the longer leg. Okay, so this is the longer leg. So it's a little tricky, but it's not that bad. So we know that this has a distance of 6. And remember, we said the longer leg has to be equal to the shorter leg, we'll just call it S, times rad 3. And so that equals our longer leg, which we know is 6. Okay, so we're just going to do a little algebra. Divide by rad 3, divide by rad 3, cancel out. S equals 6 rad 3. We're going to multiply it by rad 3 over rad 3. And we get 6 rad 3 over 3. And 6 rad 3 over 3 is the same thing as 2 rad 3. Now at this point, since we're actually plotting it on a graph, we may want to plug that into our calculators. So I'm going to plug that into my calculator here. I want to know what square root of 3 is times 2. And I got 3.46. So I'm going to write that. 3.46. Okay, well, remember, that's how far up I'm going to go. So I'm going to go up about 1, 2, 3, and then a little bit halfway maybe. And so that's about where my point P is going to be. Because remember, they told us this is a right angle. Now, if I wanted to actually know the coordinates there, well, the x-coordinate is the same as C, so it would be 3. And my y-coordinate would be, remember, we started at 2, and then we added to it 2 plus 2 rad 3. Or, we could say it's 3 comma 3.46 plus 2, right? Because here's what I added to the height of 2. So I went up 3.46. So that would be 5.46. And either one of those will work as a coordinate for P. This one, although it doesn't look like it, is actually more exact than this one. So, alright, that's it for 7.3. Kind of a long one, but a lot of good stuff in there.